Hi students, integral 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square dx is equal to this right integral 0 to 1 tan inverse of 2x is right x plus x minus 1 by 1 minus, if you take minus, this becomes right x square plus x dx, that is equal to integral 0 to 1 tan inverse of x plus x minus 1 by 1 minus, if you take x is taken common, that is x minus 1 dx. Now this is the tan inverse of x plus y by 1 minus xy. So that is equal to integral 0 to 1. So this is the tan inverse x plus tan inverse of x minus 1 dx. So this right integral 0 to 1 tan inverse of x dx plus integral 0 to 1 tan inverse of x minus 1 dx. Now for this or this, we can any one, we are using the formula integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now I am applying the formula for the first integral, for only for this part, integral 0 to 1 tan inverse of 1 minus x dx. If you take minus is taken common, tan inverse of minus x equal to minus tan inverse x. So write minus 0 to 1. So this is the tan inverse of 1 minus x dx. From this, tan inverse of minus x equal to minus tan inverse x. So these two gets cancelled, that is 0. So answer is 0. So next one, integral 0 to 2 pi. So this is log of 1 plus cos x dx is equal to log of 1 plus cos x dx equal to, just using the formula 0 to 2a property, f of x dx is equal to 2 times of integral 0 to a f of x dx. If f of 2a minus x is equal to f of x. Now this is f of x. F of 2 pi minus x equal to, so let me take f of x equal to, so this is log of 1 plus cos x. Now f of 2 pi minus x is equal to log of 1 plus cos of 2 pi minus x. That is equal to log of 1 plus cos x. That is equal to f of x. So using this property, this right 2 times of integral 0 to pi log of 1 plus cos x. dx, since the reason is this one. So that is equal to 2 times of integral 0 to pi log of 1 plus cos x formula, 1 plus cos x formula 2 cos square x by 2. So this is 2 cos square x by 2 dx. That is equal to 2 times of log of, this is AB, log A plus log B, integral 0 to pi log 2 dx plus integral 0 to pi. So this is log of cos x by 2 whole square dx. That is equal to, if for this multiplying 2 into integral of log 2 integral of 1 is x, limits for 0 to pi, plus, so this multiplying 2 into integral 0 to pi log of x to the power of m, you write m log x. This is 1 to log of x power m is m log x. So this is into log of cos x by 2 dx. So this is 2 times of log 2. Integral of 1 is, this is limit, applying limit, this is pi. So this log 2 is one term, pi is another term. So this is 4 times of integral 0 to pi log of, this is cos x by 2 dx. So this is 2 pi log 2 plus, and for this part you are considering right here 4 into 0 to pi log of, this is cos x by 2 dx, call it 1. Therefore this is the given integral. Now you have to take the part, only this part, consider the part 0 to pi log of cos x by 2. Now you take the part. So this is integral 0 to pi. So this is log of cos x by 2 dx. In this one, put x by 2 is equal to t. Dx is equal to 2 dt. Dx is 2 dt, limits. If x is equal to 0, implies t is equal to 0. If x is equal to pi, implies t is equal to pi by 2. T is pi by 2. Therefore this integral 0 to pi log of, so this is cos x by 2 dx is equal to, limits changes to 0 to, this is pi by 2. So the log of cos t, this is t, where dx is 2 dt. Dx is 2 dt. That is equal to 2 times of integral 0 to pi by 2 log of cos x dx. Okay now, since integral by using the formula integral a to b f of x dx is equal to a to b f of t dt. F of t dt. But you know the integral 0 to pi by 2 log of cos x dx is minus pi by 2 log 2. Minus pi by 2 log 2. So this value is 2 into minus pi by 2 log 2. Value of this value. So these gets cancelled. That is minus pi log 2. So this is the part, only the part, the value of this is equal to minus pi log 2. Therefore, from 1 in place of this, you write minus pi log 2. Okay, na? Therefore, from 1. From 1. Therefore, that given integral is equal to, so this is a 2 pi log 2 plus 4 into, this is minus pi log 2. That is equal to 2 pi log 2 minus 4 pi log 2, which is minus 2 pi log 2. Next one, Leibniz, Leibnitz, Leibniz rule for differentiation. Leibniz rule for differentiation under integral sign. Leibniz rule for differentiation under integral sign. So this is just one d by dx of integral some phi of x to psi of x into f of t dt is equal to derivative of integral lower limit upper limit phi of x to psi of x. Psi, this is of x, some function, or you can call it this is some h of x, this is some g of x, according to your convenient, is equal to f of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. This is the Leibniz rule for differentiation under integral sign. Derivative of phi of x to psi of x f of t dt, f of upper limit, derivative of upper limit minus f of lower limit into derivative of lower limit. This is Leibniz rule. Based on this, we have one problem. If f of x is equal to is equal to integral 1 by x to root x sin of t square dt. Then f dash of 1 is equal to so this is differentiating f dash of x equal to, by differentiating this one, f of upper limit in place of t you write upper limit, so this is a sin of root of x square, that means x into derivative of upper limit, derivative of root x is 1 by 2 root x. Okay, f of upper limit in place of t you write upper limit, so this is root of t square, that is t, root of not root in place of t write root x, root of sin of root x whole square sin x into derivative of upper limit 1 by 2 root x minus sin of in place of t you write 1 by x, so this is 1 by x square into derivative of 1 by x minus 1 by x square. Okay na, f of upper limit derivative of upper limit minus f of lower limit derivative of lower limit. Now we have to find f dash of 1 is equal to, so this is sin 1 into 1 by 2 minus this is sin in place of x write 1 sin 1 minus of minus plus, so okay, this is also 1, that is equal to 3 by 2 into sin 1. If you take 1, sin 1 is taken common, 1 by 2 plus 1, so that is 3 by 2, 3 by 2 sin 1. In another example, see, limit of x tends to 0, integral 0 to x square cos t square dt by x sin x is equal to, so if you are applying the limit of x tends to 0, in place of x write 0, integral a to a f of x dx 0, integral 0 to 0 f of x dx is 0, so this is 0 by 0 form. If it is 0 by 0 form, then you have to go for L'Hospital rule. L'Hospital rule is applicable only for it is 0 by 0 form or infinity by infinity form. So in place of x tends to 0, integral 0 to 0, so the value becomes 0, so this is 0 by 0 form. Now differentiating by using L'Hospital rule, that is limit of x tends to 0, this is called by using this one Leibniz rule. So cos of in place of t you write x square, so this is x power 4 into derivative of x square 2x minus cos 0 in place of t write 0 into derivative of 0 is 0 by, so this is uv form, x into derivative of sin x is cos x plus sin x into derivative of x is 1. Okay, that is equal to, so this is limit of x tends to 0, so this is 2x into cos x power 4 by x is taking common, so this is cos x plus sin x by x, so x gets cancelled. Now we are applying the limit, numerator is 1 by cos 0 value 1, sin x by x is 1, therefore which is 1 by 2. So another example based on Leibniz rule. This is also previous IIT question. Limit x tends to pi by 4. Integral 2 to secant square x into f of t dt by x square minus pi square by 16 is equal to 8 by pi into f of 2 pi by 8 into f of 2 8 f of 2 by 3 pi, and this is minus 8 by pi into f of 2. These are options. See, when you are applying the limit, secant 45 degrees is root 2, secant square 45 degrees is 2. So this is integral 2 to 2 f of t dt, which is 0. And in place of x, write pi by 4. So pi square by, this means pi square by 16 minus pi square by 16. So this is of the form 0 by 0 form. Now we are go for L'Hospital rule. So L'Hospital rule, Leibniz rule, that is derivative of this f of upper limit secant square x into derivative of secant square x, 2 secant x into 2 secant x, derivative of secant x is secant x into tan x minus 0, because f of 2 into derivative of 2 is 0 by, so this is limit of x tends to pi by 4. Now this derivative is 2x. 2x. Now we are applying the limit. So the value pi by 4 root 2 whole square, that is 2. So this is f of 2 into 2 into, so this is root 2 into, this is root 2 into tan pi by 4, 1 by 2 into pi by 4. Okay, 2 into pi by 4. So this 2 and this 2 gets cancelled, that is equal to 2 into f of 2 by pi by 4, that is 8 by pi into f of 2. Next one, next one, based on properties, let f be a positive function and let I1 is equal to I1 integral 1 minus k to k x into f of x into 1 minus x dx, and I2 is equal to I2 integral 1 minus k upper limit is k f of x into 1 minus x dx, then I1 by I2 is equal to I1 by I2 equal to, now we take the first integral first integral I1 is equal to integral 1 minus k to k. So this is x into f of x into 1 minus x dx. Here you are using integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Using this property. Now this is equal to that I1 is equal to integral 1 minus k to k, where x you write 1 minus k plus k, where f of x is a plus b minus x. So this is 1 minus k plus k, that becomes what? 1 minus x. This is a, this is b. In place of x, right? A plus b minus x, that is 1 minus k plus k minus x, which is 1 minus x in place of x. So this is 1 minus x into f of, where x is 1 minus x into 1 minus x is, 1 minus x means what? 1 minus of, so this is 1 minus of 1 minus x, which is x dx. Okay, I think you are able to understand. If not, you can write in detail 1 minus k plus k minus x. There k gets cancelled, that is minus x. Now if you are multiplying this, so this is 1 into integral 1 minus k to k. So 1 into, so f of 1 minus x into x is nothing but x into 1 minus x dx minus integral 1 minus k to k, x into this, x into f of x into 1 minus x dx. Okay, so this is I1. So that is I1 is equal to, this integral is I2. This is I2 minus, and this is I1. Therefore, 2I1 is equal to I2. I2. Therefore, I1 by I2 is equal to 1 by 2. So that is 1 by 2 is the correct answer. Okay, write down. So you have another problem based on the same model. Let f be a continuous function. Let f be a continuous function and let I1 is equal to integral sin square t, lower limit 1 plus cos square t. upper limit, x into f of x into 2 minus x dx, I1, and I2 is equal to integral sin square t, upper limit 1 plus cos square t. So this is of x into 2 minus x dx. Now I1 by I2 is equal to, now I1 by I2 is equal to, for this also you are applying the same formula. So properties are very important for indefinite integration. With the help of integration and use indefinite integration and use the properties, definite integral properties. So using the same, what is the formula? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Now this is I1 is equal to, this is I1 integral, so this is a sin square t 1 plus cos square t. So where x you write, this is a, this is b. So sin square t plus 1 plus cos square t minus x. Sin square t plus cos square t is 1. Already 1 is there. So 2 minus x. Where x you write sin square t plus 1 plus cos square t minus x. So this is 1 and this is 1. So 2 minus x. In place of x, you write 2 minus x. So this is 2 minus x into, this is f of 2 minus x into, okay, now 2 minus x means x dx. Again in the same, so multiplying this 2, so this is integral, so sin square t into integral, this is 1 plus cos square t 2, that means a 2 I can write outside, f of x into 2 minus x dx. Next minus x into minus integral, so this is a sin square t 1 plus cos square t x into f of x into 2 minus x dx. Now this is I1. I1 is equal to, so this is 2, this is I2, given I2 minus, again this is I1, this is I1. So 2I1 is equal to 2I2. 2 gets cancelled. Therefore, I1 by 2 equal to 1 is the correct answer. Next one. Next one, integral 0 to sin square x sin square x into sin inverse of root to t dt plus integral 0 to cos square x into cos inverse of root to t dt is equal to, their first option pi by 4, pi by 2, pi by 6, pi by 3. So there are two methods. First one, t is equal to sin square alpha. In this, t is equal to cos square alpha. This is one process. And the other one, by using Leibniz rule. So that is very simple. Let this is some f of x equal to. This is f of x equal to. Now f dash of x differentiating by using Leibniz rule. So f of upper limit into derivative of upper limit. So this is sin inverse of root of sin square x, that is sin x, into derivative of upper limit 2 sin x into cos x. Okay, minus this is what, sin inverse of 0 into derivative of 0 is 0. So that is 0. Next, that is minus, that part is 0. Next plus for this. F of upper limit in place of t, write cos square x, that is cos inverse of root of cos square cos x into derivative of this 2 cos x into minus sin x. Derivative of cos x is minus sin x. Therefore this is x into, so this is sin 2x. Okay, and minus, of course next part becomes 0 because cos inverse of 0 into derivative of 0 is 0. So this is x, okay, minus x into, so this is sin 2x. Therefore this is 0. F dash of x equal to 0 means what? F of x is constant. Implies f of x is constant function. Constant means what? F of anything is, that is always constant. Constant means what? F of x is equal to k for all x belongs to k, for all x belongs to R. F of 0 is k, f of 1 is k, f of anything is k. So for that I put here f of pi by 4. Why I am putting pi by 4? To equating the limits. That is integral 0 to, so pi by 4 is what? So sin 45 degrees is 1 by root 2. Sin square is 1 by 2. 1 by 2, this is sin inverse of root to t dt plus integral 0 to, this is also 1 by 2. Suppose if you take the other value, the limits are different. And cos inverse of root to t dt. Therefore that is integral 0 to 1 by 2. So this is sin inverse of root to t plus cos inverse of root to t dt. So sin inverse x plus cos inverse x is pi by 2 if x belongs to minus 1 comma 1 in its domain, minus 1 to 1. So 0 to 1 by 2 means what? It is valid. So that is equal to integral 0 to pi by 2, this is 1 by 2. 1 by 2. So this is pi by 2 dt. Okay now. So this is pi by 2. Integral of 1 is t. Limits for 0 to 1 by 2. That is equal to pi by 4 is the answer. Next one, if integral e to x t into f of t dt is equal to sin x minus x minus x cos x minus x square by 2 for all x belongs to r minus 0. Then f of pi by 6 is equal to f of pi by 6. For this also you are using Leibniz rule for differentiation. So Leibniz rule for differentiation and integral sign. So in place of t, you write x into differentiating x into f of x into derivative of x is 1 minus e into f of e, derivative of e is 0, is equal to derivative. So this is cos x minus of uv form x into derivative of cos x is minus sin x plus cos x into derivative of x is 1 minus 2x by 2, 2 to cancel, that is equal to cos x, where x not equal to 0, cos x plus x sin x minus cos x. Okay, na? Cos x cancel and minus x. Okay, if you take x is taking common, so this is sin x minus 1. Sin x minus 1. So this is x into f of x. What is given? X not equal to 0. Therefore, gets cancelled. F of x is equal to sin x minus 1. Now we have to find f of pi by 6. That means what? Sin pi by 6 minus 1. Sin pi by 6 means what? Sin 30. Sin 30 value 1 by 2 minus 1. That is minus 1 by 2 is the answer. So based on Leibniz theorem also we are having some problems. Sometimes they came in mains exam as well as advanced exam. Okay, na? So we have to solve the problems which are related to these type of problems. Next class you go for the properties of, that means periodic function and its applications. Okay, thank you.